Students, this is the video solutions for test conducted on 23rd, that is the last Monday. This is basically on isomerism, few the other topics, and so it's a very easy test. And the one thing is the compound with the stereochemical structure following configuration at the double bonds. The molecule is given and he is asking to find out the configuration, EZ notation at the different carbon atoms. You see here it is this center, this is trans relation, 1 opposite side, so E is correct. For first one is the E, second one is the 1 is same side, that is Z notation. This is the again 1 is one side, that is Z notation. This is E notation. So now it is E, Z, Z, E is correct. That is C is correct. See, the other one is here he has given the bifunctional compound, asking the what to give the IUPAC name. If you see the ranking of if it is a bifunctional compound, to assign the IUPAC name, first we must know the ranking order, which to be taken as the principal function group. Here, this is the ester group, this is the acid chloride. So it to be considered as the ester group. Priority to be given as the ester over the acid chloride. If the acid chloride, this is the prefix for the acid chloride is the chlorocarbonyl. This is the cyclohexyl benzoate. So ester, first we have to tell the alcohol part, cyclohexyl. Now acid part as benzoate. Some substituent is there. 2. What is there? That is the chlorocarbonyl. Cyclohexyl 2-chlorocarbonyl benzoate. Cyclopentyl 2-chlorocarbonyl benzoate. It's a cyclopentyl group. D is correct. This is the D is correct one. Now, in this compound, which of the following compound can have meso isomer also? See, to show meso isomer, it should contain the chiral centers, 2 or more chiral centers, and plane of symmetry or center of symmetry that is required. If the molecule contains the 2 chiral centers, 2 similar chiral centers, that shows the mesomerism. Mesomerism means that can form the mesoisomer like tartaric acid. This is here 2-bromo 3-hydroxybutane. This is the 2-bromo 3-hydroxybutane contains the this is the compound 2-bromo 3-hydroxy, or other way the name is not properly given, that is the priority to be given to the alcohol functional group. This is the molecule for first molecule where 2 chiral centers are there, 2 dissimilar chiral centers, right? So this 4 optical isomers are possible, 2 pairs of enantiomers. Meso compound is not possible. The other one is the 2,3-dimethyl cyclobutane. You see, 2,3-dimethyl cyclobutane system, this is the it can have the cis and trans. There are two chiral centers. Cis form is that is plane of symmetry. Therefore, it is possible here. It is a meso compound. And next one is the third one, 2,3-dihydroxy. Again here, 2,3-dihydroxy pentane, not pentane. 2,3-dibromo. Yes, this is the 2,3-dibromo. You see, this is the molecule. 2,3-dibromo. So there are two chiral centers. This is chiral center, this is chiral center, and two similar chiral centers. Therefore, definitely what I have taken here, the structure, Fischer projection is the meso compound. There is a plane of symmetry. So here possible. Pentane 2,3-diol. You see pentane 2,3-diol, this is the molecule. These two are not same. Two chiral centers, two dissimilar chiral centers. Here ethyl group and here methyl group. So it's not possible. 4 optical isomers are possible. Meso compound is not possible. Therefore here meso compound is possible only in case of 1,2-dimethyl cyclobutane. Butane, yeah, I have taken the cyclopropane, cyclobutane you have to take. That is the, and same, this is the 1,2-dimethyl. Both are cyclobutane. This is chiral, plane of symmetry. Therefore meso, this is meso. Cyclopropane తీసుకున్నాను, తప్పు తీసుకున్నాను. So that is here the correct answer is B. 2, 3 is correct. This is the next one is the, see the names are given, incorrect IUPAC name. See for this you see, for this compound you see, this is wrong. This is fourth one is wrong. 1-ethyl. No, numbering is like this I have shown here. So the one from that side 1, 2, 4 are the locants. That is the first point of difference. From if you number from this side 1, 3, 4. So this is the first point of difference. This is correct. 1 to 4 is correct. So if that is the case, ethyl 4-ethyl. This is 4-ethyl. I have given the 4-ethyl, 2-methyl, 1-propyl, cyclohexane is the correct name. He has given the wrong name. 1-ethyl. The numbering is wrong. Here, the isopropyl hexane, no, yes, violating the that is the longest chain rule, parent selection of the parent chain. This contains the 6 carbon atom. This also contains the 6 carbon atoms and more number of branches. The chain which contains the equal number of carbon atoms, more number of. So this is the first. This is numbering 3-ethyl, 2-methyl. This is, and hexane is the name of the compound. The isopropyl is not correct. You should not call it as the isopropyl hexane. So that is the D is the correct one. This is 4, 3, 4. 3, 4 are wrong names. So this is the D is correct option for this. The next one is the Gaussian conformer is more stable than anti-conformer. Where you see, I have given this Gaussian conformer and this are given. So this is possible in case of the ethylene chlorohydrin. This is OH and intramolecular hydrogen bonding. Here amino group 1 amino 2 chloroethane, that is aminoethane, chloroethane, 2 chloroethane amine. So whatever it is, the hydrogen bonding is possible between the hydrogen of the amino group and chlorine of the next one. This Gaussian form is intramolecular hydrogen bonding is possible. So it is possible in this molecule as well as in this molecule. That is 2, 4 are correct. That is A is correct option for this. In the other compound difluoroethane, this is the 1,2-dibromoethane. This is not possible. Next, in the following compounds, and which of the following statements is correct? 1, 2, 3 are chiral. Yes, this is trans. You see, this is above the plane, this is below the plane. No, this is below the plane. No plane of symmetry, no center of symmetry. This is chiral center, no plane of symmetry. Therefore, it is it is a chiral molecule. 1 is chiral, correct. 2. See, 1 is above the plane, other is below the plane. But chlorine, it's a reflection point. This is also chiral. Now chlorine, methyl, no plane of symmetry. This is chiral center, this is chiral center. Right? This is chiral center. Cl, at the reflection point, methyl is present. No plane of symmetry. So chiral molecule, this is also chiral. But here is a plane of symmetry. Methyl, methyl, 1, 3 positions, chlorine, so that is the plane of symmetry. This is 1, 3 positions. This is a plane of symmetry. It is a chiral. It has the plane of symmetry. Therefore, 1, 2, 3 are correct. What is the correct option for the 1, 2, 3? So B is the correct option for the 1, 2, 3 chiral. And next one is this is the case. Erythro-trio isomers are possible. To say the erythro-trio, there must be 2 chiral centers. So here you see 1, 3 chloro, 2 butanol. There are 2 chiral centers, you see. Fisher projection to the highly preferred group, same side. This is trio, erythro. This is erythroform, possible. 1, 4 dibromobutane, no chiral center at all. This is the 1, 4. There is no chiral center at all. Not possible. 1, 2 dibromo, 1 phenyl propane. 1, 2, 3 propane, 1, 2 dibromo, 1 phenyl. There are 2 chiral centers, you check up. When there is a 2 chiral centers, that is the erythro-trio, both are possible. This is possible. Butane 1, 2 diol. There is only 1 chiral center in the butane 1, 2 diol. The butane 1, 2 diol, there is only 1 chiral center. That is 1, 2, 3, 4. 1, 2 diol. This is not a chiral center. This is a chiral center. Erythro-trio concept is valid to the system where minimum 2 carbon atoms are present. Sorry, 2 chiral centers are present. Therefore, here, that is 1, 3 are correct. That is C is your correct option. Next one is, and is asking which of the following compounds have 2R, 3S. He only designated the centers. This is SR. This is and see RR. You check up the configuration. RS. RS is required. This is SR. This is RR. The RS. This is also RS. You check up you in the given molecule. You can find out. Therefore, that is the 3 and 4. These two are have the 2R, 3S configuration. Therefore, only 3 and 4. D is correct option for it. D is the correct option. And next one is the See, tartaric acid is given. Optically active compound X has a structural formula of, that is in the this. They should have the same configuration at the both, that is RR configuration. If the at this center configuration is opposite to this center, the tartaric acid, the internal R effect is nullified by the this one. RR SS is possible. RR in one optical isomer, SS is another optical isomer. This is the enantiomeric pair. SR is the meso. SR is the R, opposite configuration is effect of the R is nullified by the S, therefore internal compensation takes place. S effect is nullified by the R center, therefore it's possible. Therefore 3 and 4 are correct options. So this is B is correct for this. Now he has given the some options and are asking the which of the following has the S configuration at the chiral centers. See, this is S, this is S, this is S, this is R configuration. R configuration. Therefore, and here the 2, 3, 4 are the 2, molecule 3, molecule 4 are the correct option. Here the options are not given, ABCD options are not given. So I have divided. This is the option in which the word 2, 3, 4 are taken. This is not, this is R. This is R configuration. You check up. And this is cyclic system. That is up. This is the G. I will take this as G. If I turn like this, this is the double bond O part. This is the remaining part. This is hydrogen. First priority comes to this, second priority this, third priority this, C double bond. No. Yes, this and correct. This and this. Therefore, this is wrongly yes, rightly or. Remaining things easy and that's which of the following is correct about the anti and Gaussian conformers of the N-butane. Gaussian conformer is less stable, less stable because of torsional strain. No, it's not torsional strain. That is the torsional strain is different. That is the energy required to change the additional energy required to convert the word Gaussian form into eclipsed form. It's not correct. So Gaussian conformer is less stable because of the van der Waals strain. Yes, repulsions because the adjacent groups. C1 groups and 60 degrees van der Waals repulsions. Very low temperatures, anti-conformer is present. Yes, anti-form is more stable. Therefore, under low temperature conditions, it solidifies in the only in the Gaussian conformer. Sorry, in the anti-conformer, opposite conformer. That is, they are configurationally isomers. No, they are conformational. Configurational, not due to single bond rotation they are formed. Therefore, it's not correct. This is not correct. So that is only the 2 and 3 are correct. So B is correct. This is here, you check up this, it is not a chiral molecule at all. I define the word dissymmetry, asymmetry. A chiral molecule with C2 axis is called as the dissymmetric molecule. Chiral molecule. Basically, the chiral kavali. This is not the chiral molecule, you see. Allene, but AABB type. It's not a chiral molecule at all. This is allene, chiral molecule. Therefore, it is it has the AB type, has that is a dissymmetric system. C2 axis on the it is not a chiral molecule at all. It is not a chiral molecule at all. This is chiral molecule. That is, this also has the, on rotation of the 180 degrees, this will become this and this will become this. C2 axis is present. So 2 and 4 has the C2 axis. Chiral undi C2 axis kavali. C2 axis unnadanni disymmetric kaadu adi. Chiral molecule with C2 axis called as the. Now, this is, you see here, which of the following substituted benzene derivatives would furnish the 3 isomers when one more substituent is introduced on the benzene ring? 1 bromo. How many centers are there? You check up. This is the ortho, meta, para. Third group can be, second group can be anywhere. Therefore, for this, how many isomers are possible? 3 isomers are possible. 3 isomers possible. Here, how many are possible? 2 are possible. Because here, this is ortho, these 2 are equivalent. These 2 are equivalent. So, 2 isomeric compounds are possible. And whereas in this case, and how many? Oh, this is one center, this is another center, this is third center. These are the 3 position isomers are possible. So for this, 3 are possible. And here, all are equivalent, you see. Wherever you introduce that, you will get the same product. That is, therefore, this is only 1 is possible. So substituted benzene derivatives would furnish the 3 isomers. So 3 isomers ichedi only 1 and 3. 1, 3 are correct. This is D is correct option for this. Now it is, which of the following statement is or correct? Restricted of free rotation about the carbon-carbon single bond may result in enantiomerism in the appropriately substituted this one. Correct. And enantiomers differ in their biological activity. Yes, they differ in the biological. Out of the R and S, only one is a dextro and levo, only one is biologically active, other is biologically inactive. Diastereomers have the same bond connectivity. Diastereomers are, yes, they are stereoisomers. Therefore, the same bond connectivity and same magnitude of the specific rotation. This is wrong. No. So, cistrons isomers also diastereomers. How can we tell they have the same magnitude of the rotation? No. Presence of the chiral axis also makes a compound optically active. Yes, this is also correct. Chiral axis unna optically active. 1, 2, 4 are correct and 3 is wrong. Therefore, A is correct. 1 bromo 2 methyl cyclopropane can exist as Suddham. 1 bromo here 1 bromo 2 methyl. There are 2 chiral centers. Check up. Indra Ade Rasana 1 bromo 2 methyl cyclopropane. Any chiral centers are similar or dissimilar? Dissimilar. N is equal to 2. Rule is 2 to the power of n. How many optical isomers are possible? 4 optical isomers are possible. 4 optically active isomers. Only 1 pair of enantiomers. No, 2 pairs of enantiomers. And a pair of geometrical isomers. Yes, this is cis and trans. Out of the 4, 1 they have the cis-trans relation. Cis has the DL pair, trans has the DL pair. This is the trans DL pair. Cis, one pair of geometrical isomers, that is the position isomers. No, he is selling the 1 bromo 2 methyl. When the name is given, you can't change the word position, and bromine position cannot be changed. Therefore, that is the, and what is correct? These 2 are correct. 3, 2, 4 are wrong. and 1, 3 are correct. B is the correct option. That is here the worked out. You see, and here it is consider the following compounds. Yes, compounds having two geometrical isomers. For this it is possible. Cyclohexane, two geometrical isomers. He is asking only geometrical isomers. Disubstitute. This is C2H5. Cis and trans naturally. Here all disubstituted shows the except one that is C2H5. CH3, CH3 possible. So cis trans is satisfying the condition. This also all can be one side, two can be one side and one can be opposite side. Here also cis and trans possible. And here and two can be same side, two can be opposite side. That is the one is above the plane and other is below the plane. And all the cases it is possible. All the four. D is correct option for this. Next one is the Dumas method involve the determination of the nitrogen content in the organic compound in the form of. So in the Dumas method, nitrogen is estimated by converting into the nitrogen gas. This information oriented. B is correct. And ade Geldahl's method it is estimated by converting the nitrogen into ammonia in the Geldahl's method. Right? This is A for the Geldahl's method, B for the Dumas method. Dumas method is universal. So consider the following structure and pick by the right statement. That is the right statement. Then configuration decide R. This is yes. 1, 2 are determination in configuration. You can find out the configuration. This is the first priority. This is second priority. This is third priority. This is least priority. Exchange చేసుకోండి చూసుకోండి చేయండి అక్కడ అదే వస్తుంది. 1, 2 are R configuration and 3 has the S configuration. Yes, this is correct. So 1, 2 have R configuration. 1, 3 have R configuration. No. The 3 has the S configuration. Not correct. Only 3 has S configuration. 3 has S configuration. This is also correct. 3 has the S configuration. S configuration B. Yes. Correct. Only 3 has the S configuration. 1, 3 have the S configuration. No, this is wrong. 1, 2 have the R configuration. Only 3 has the S. This is correct. 1 and 3 have the R configuration. No, wrong. And this. Here the A and C are correct. A, C both are correct. The combination This is mark out the correct match. Geometrical isomer. They are not geometrical isomers. They are structural isomers. Because ethyl and phenyl are on same carbon. Methyl and phenyl are same carbon. Structurally different. They cannot be the geometrical isomers. Structurally they have the different IUPAC names. So this is 3-phenyl 2-pentene. This is 3-phenyl. This is 2-phenyl. So So they are not, they are structurally different. That is the next one is the are geometrical isomers. How can they be position isomers? Student, geometrical isomers should have the same structure. So that is the position of the this is changed. OH and bromine have the 1-2 relation, here the 1-4 relation. They cannot be the, they are structural isomers. Andra kuda position isomers aithe. The next one is the one structurally different, they are structural isomers. These are the metamers, correct? They are metamers, ester, both are esters, and they differ in the nature of the groups connected to the polyvalent function groups. So ethyl, methyl, hydrogen and propyl, metamers. This is functional isomers. Yes, this is ketone, this is phenol, both are isomers and they are functional isomers. So that is 3 and 4 are correct. 3, 4 are correct. This is correct. So this is D, option D is correct for this. Next one is the, this is the recent question, classroom question, and very simple, and so that is the paranitrophenol, orthonitrophenol, that is metanitrophenol, paranitrophenol, and next orthonitrophenol, intramolecular. Here only minus I effect, minus I, minus M, minus M, minus M, minus I, and this is phenol, this is this one, minus 1. Minus M, minus I increase, the phenol is least, and the other 3 are stronger. అందులో కూడా ఏముంది మైనస్ ఎం మైనస్ ఐ మైనస్ ఎం మైనస్ ఐ ఇది ఉండాలి ఆర్థో ఉండాలి ఎక్స్పెక్టెడ్ ఈజ్ ఆర్థో షుడ్ బి మోర్ దాన్ దట్ ఆఫ్ దిస్ వన్ బికాస్ ఆఫ్ ద ఇంట్రామాలిక్యులర్ హైడ్రోజన్ బాండింగ్ లిటిల్ ఇట్స్ డిక్రీజ్డ్ పారా దట్ ఈస్ ఆర్థో మెటా దట్ ఈస్ ఫినాల్ సో దిస్ ఈస్ కరెక్ట్ 1 2 3 4 this is correct and A is the correct option for this. And this is aniline, nitroaniline, metanitroaniline. This is C is correct here. C, aniline, minus electronic effects increase the acidic properties, plus properties decrease the plus effects, minus effects increase the basic properties. This is the nitroaniline, orthonitroaniline, ortho effect, metanitroaniline, minus I effect, and paranitroaniline. Minus M, minus I, minus I, yes. This is ఆర్థో ఎఫెక్ట్, డామినేటింగ్ ఎఫెక్ట్ బాగా డిక్రీజ్ అయిపోతుంది. ఇది అన్నిటికంటే బెస్ట్. దిస్ ఈస్ ద అనిలిన్ బెస్ట్. నో ఎలక్ట్రానిక్ ఎఫెక్ట్. అన్ని బ్యాడ్ ఎఫెక్ట్సే ఉన్నాయి. దే డిక్రీజ్ ద ఎలక్ట్రాన్ డెన్సిటీ. సో ద నెక్స్ట్ వన్ ఈజ్ మైనస్ ఐ ఎఫెక్ట్ ఈజ్ బెటర్ దెన్ minus I effect is better. That is third one is next. Next ortho and this. Ortho effect is least and ortho isomer is least acidic, least basic and irrespective of its electronic effects because ortho effect in aniline. So this is the ortho effect minus M and minus M. This is the order. Manam classroom lo chesina ivi. How many stereoisomers exist in the compound 1-methyl 3,1-chloro-propynyl cyclohexane? And this is the structure of the molecule. You see, there are two chiral centers. Two stereo centers. స్టీరియో సెంటర్స్ 2 ఉన్నాయి. టోటల్ నెంబర్ ఆఫ్ స్టీరియో ఐసోమర్స్ ఎన్ని వస్తాయంటే 2 to the power of n. That is equal to, there are 3, I forgotten to tell you. Starred centers are 1, 3 and this is double bond center. 2 to the power of 3, 8 are possible. So 8 is the correct option. I have given 3 stereo centers, 3. Therefore 8 is the, here it is very simple and a molecule is given, is asking to find out that's the number of chiral centers in the molecule. So all the starred centers are chiral centers. You check out with red spots. Red, this is chiral, this is chiral, this is chiral center, this is chiral center, this is chiral center, this is chiral center, this is, if you count the red points, 8, that is the 8 is the correct option. And how many pairs of diastereomers can be made for the compound shown below? ఎన్ని ఉన్నాయి చూడండి ఇక్కడ. This is 3 centers. 1 pseudo chiral center ఉంది, odd number, that is also taken as the chiral center. So 2 and it can be bisected into 2 equal halves. Odd number of ఇది ఉన్నాయి. Plane of symmetry ఉంది, it can be bisected through the carbon atom. 2 plane of symmetry, symmetrical గా ఉంది. కాబట్టి అప్పుడు రూల్ ఏంది, టోటల్ 2 to the power of n. 2 to the power of n means 3 minus 1, that is equal to 4 are possible. Total isomers, total stereo isomers 4 ఉంటాయి, ఆప్టికల్ ప్లస్ ఇది. అండ్ మీసో ఎంత అవుతుందంటే 2 to the power of n minus 1 by 2. ఇవి మీసో. This is 2 to the power of 3 minus 1 by 2, that is 2 by 2, that is and 2 are possible. కాబట్టి 2 ఇవైనాయి. సో ఆప్టికల్ ఐసోమర్స్ 2, ఆప్టికల్ ఐసోమర్స్ ఎనాన్షియోమెరిక్ పేర్ ఆప్టికల్ 2, మీసో 2. అంటే నేను రాస్తున్నదండి ABRDL pair, CDR మీసో కాంపౌండ్స్. ఇప్పుడు చూడండి ఎన్ని పేర్స్ అయితే చూడండి. ఇందులో నుంచి CD is 1 pair, stereo isomers which are not enantiomers. AC is 1, AC is 1, BC is 1 pair, B and C. Now AD is 1, means that's a diastereomeric pair, and ఏమైతుంది BD is 1 diastereomeric pair. So 1, 2, 3, 4, 5 pairs are possible. కాబట్టి 5 how many pairs of diastereomers? Check up. The last one is the chlorination అంటున్నాడు. ఈయన ఏం చేస్తున్నాడు, దట్ ఈస్ అండ్ లెట్ మీ టేక్ ద డైఇథైల్ మిథైల్ కదా, ఇది తీసుకున్నాడు అంతేనా, ఇది తీసుకున్నాడు. క్లోరినేషన్ చేయండి అండ్ హౌ మెనీ ఐసోమెరిక్ మోనోక్లోరో డెరివేటివ్స్ ఆర్ పాసిబుల్ అన్నాడు. కరెక్టే నేను తీసుకున్నది కదండి. ఇక్కడ రావచ్చు క్లోరిన్, ఇగో ఇక్కడ రావచ్చు క్లోరిన్. నేను పొజిషన్ వైజ్ రాస్తా. ఇంకా ఇక్కడ రావచ్చు, ఇంకా ఫోర్త్ది హియర్ ఇట్ ఈస్ పాసిబుల్, దిస్ ఈస్ పాసిబుల్. ఇంకా రాదు, ఇటువైపు పోతే డూప్లికేషన్ అవుతుంది. అన్ని 4 పొజిషన్ ఐసోమర్స్ అయితే 4. కానీ ఇప్పుడు చూడండి ఇది ఇక్కడ వన్స్ క్లోరిన్ ఈజ్ ఇంట్రడ్యూస్డ్, ఈ మాలిక్యూల్లోకి నో కైరాల్ సెంటర్. వన్స్ క్లోరిన్ ఈజ్ ఇంట్రడ్యూస్డ్ దిస్ బికమ్ ద కైరాల్ సెంటర్. కాబట్టి కైరాల్ సెంటర్ అయింది కాబట్టి ఏమొస్తుంది అండ్ 2 పాసిబుల్ అవుతుంది ఆరు ఎస్ 2 ఆర్ పాసిబుల్ స్ట్రక్చరల్లీ 1 స్టీరియోకెమికల్లీ 2 this is stereochemically 2 are possible. Now here you see this is chlorine second and this is chiral center, this is also chiral center. So chiral centers రెండు వచ్చినాయి ఇక్కడ dissimilar chiral centers రెండు వచ్చినాయి 2 chiral centers are created. So dissimilar 2 to the power of n role 4 isomeric forms are possible. This is no chiral center here. It's not a ethyl similar groups and no chiral. Only one is possible here. And now if you come to this one, for last one, here no one, only one, no chiral center. This is not a chiral center. 2 ethyls are there. Therefore total how many are possible? 2 plus 4 5 6 7. This is 8. Total 8 are possible. So chiral centers are created. Once chlorine is introduced on this and this becomes the what chiral center. Therefore this is that's all. So this is the something explanation about this thing. If you have any doubts and you ask in the classroom and